All right, getting into our fifth lesson in our transformations unit, looking at rotations. Now, rotations, we're going to have a lot of rules as far as how we rotate figures and changing the points. You're going to get a separate sheet with those rules written out for you to keep track of, keep up with that sheet, make sure we don't lose it, because it's going to be vital as far as we move forward, understanding the rules with rotations. All right, warm-up activity, just redrawing each one of these figures as it's shown. All right, first one, A, 180 degrees. Think of it, 180 degrees is almost like a flip horizontally. So it's going to look like this, as if it was rotated around 180 degrees. 180 degrees makes a straight line, so it's flipped completely all the way around, past 90, and then we keep going. 90 degrees counterclockwise. So if we make that counterclockwise 90 degrees, it's going to be standing on this end as the bottom. See how good my drawing is here. It's going to look something like that. And then for C, 90 degrees clockwise. So clockwise, we're talking about moving this direction and moving that 90 degrees. That shaded side is now going to be on the bottom. Try my best here to draw that. It looks something like that. Not the best drawing, but my best attempt at drawing that there. All right, so our goal is here, rotating geometric figures on the coordinate plane, 90 degrees, 180 degrees, 270 degrees, and 360. And we're going to look at those effects, what happens when we make those rotations, and identify congruent figures. All right, so getting started here, I'll just let you try this on your own. All we're looking at here is just which puzzle pieces can fill those missing spots. And it's just getting you to recognize that you can take a, in this case, puzzle piece and rotate it around different directions to get it to fit into one of those spots. Anytime you've made a puzzle, you've done this before. You've taken a piece and you've sat there and spun it till you found it, one that would fit into that missing hole. So what you will discover is that for number one, to fit in spot one is piece B. And what happened really is it was reflected horizontally and then reflected vertically and then rotated around. But in other words, we've spun it around to make it fit in. Again, think of like you've completing a puzzle. And then for two, you'll find that piece A fits in. So you've done this before. Like I said, I'm pretty sure probably everyone's done a puzzle. We've all taken pieces before, manipulated them by rotating them around until we find how they can fit in that missing spot. All right, so in this activity, first one, 5.1, we're going to investigate rotating a pre-image to understand how the rotation affects the change. Now, if you have patty paper, you can trace this on patty paper, put that point of rotation, hold it down with your pencil and rotate it. But we're going to look specifically throughout this lesson at just using our rules till we know how the figure is moving. So, marking the origin, if you are doing it on patty paper, we're going to skip down to C, where rotate the figure 180 degrees about the center of rotation, and then identify the coordinates of the rotated figure and draw the rotated figure on the coordinate plane. Now, when you rotate 180 degrees, what you're doing is you're flipping it completely over. It's moving all the way around. Think of it as like a flip, essentially. It's moving all the way around into a straight line. What that does is if we have a point XY, got my comma there. If we have a point XY, what that's going to do is it's going to be the inverse of both the X value and Y value. So it's going to become negative X, negative Y. And that's our rule we're going to use when we talk about 180 degree rotations. Now, when we're going 180 degrees, it doesn't matter if we go clockwise or counterclockwise because we're ending up completely around on the other side, 180 degrees. Again, think of a straight line. So it doesn't matter if it's 180 clockwise or counterclockwise. That is still our rule. So using that, we would have new points of just changing to the inverse of the X and the Y. So this would become -2, -1, -2, -3, -4, -5, and so on. I'm just going to go through and fill these in. So there would be our coordinates of that new figure. And I'm not going to go through and plot every single one of them, but if you did, you would find that we have our rotation around 180 degrees. It's going to end up down here in this quadrant, quadrant 4. I'll go through it and plot them. We'll go ahead and do it. -2, -1, -2, -3, -4, -5, -2, -5, -2, -6. Oh, I missed one there. Let's go back. -2, -5 would be here. And -4, -5 was here. There we go. All right, now continuing. Then we got -2, -6. Then we got -5, -6. -5, -5. -4, -2. -5, -2. And my screen changed. Oh, it disappeared on me. All right, well, I'm not going to go back through and replot all those, but I would take the time on your own to go through and plot all those. It's kind of hard on my screen here to get them exactly right. The screen kind of moves around with my pen. So go through and plot those on your paper, and you're going to find that you're going to see the rotated image 180 degrees rotated down into this quadrant 4, or quadrant 3 down here, I should say. All right, next page. So we're given a parallelogram. It says place patty paper on the coordinate plane. Again, if you're doing this manually, take some patty paper, trace it, put your point at the origin, and rotate it around by the rule. So we're now going to use the rule for B, rotate the figure 90 degrees counterclockwise. So let's look at our rule for 90 degrees counterclockwise. That rule for 90 degrees counterclockwise is that it's going to become -yx. So keeping that in mind, if we're going to take all these original points, it's going to be on the top of the next page, we're going to write that, and we're going to use that rule for 90 degrees counterclockwise. Again, those rules are all on that separate sheet going to be given you. All right, so if we do that, the coordinates of that pre-image, again, A, B, C, D, and this is our new A, new B, new C, new D. So original pre-image, -1, 6, 2, 4, 3, 0, 0, 2. And again, we're following that rule of -yx. So in other words, if the y was 6, that now becomes -6 in the x value. And then our x moves to the y value. So -6, -1 is our new point. For our new b, we got -4, 2. For our new c, now there is no -0, so it's just going to be 0, 3. And then our new d value is going to be -2, 0. So part D, compare the coordinates of the image with the coordinates of the pre-image. How are the values of the coordinates the same? How are they different? Again, it followed the 90-degree counterclockwise movement, where the point x, y becomes -yx. Okay, that will find your new coordinates anytime you need to rotate 90 degrees counterclockwise. Okay, 3, make a conjecture about how a counterclockwise 90-degree rotation and 180-degree rotation affect the coordinates of the point x, y. So We just talked about a 90-degree counterclockwise rotation, a 180-degree rotation is going to follow the rule we talked about, I think 2 pages ago it was. XY simply becomes negative X, negative Y. Because 180 degrees rotates completely around in a line to the other side. So there would be our rule for a 180-degree rotation. And again, the 90-degree counterclockwise is the one right above there that we just wrote. Okay, if we go down to the next page, great little diagram here to look at what that rotation actually looks like. So it says we're going to rotate a point 90 degrees counterclockwise about the origin. So again, counterclockwise is moving this direction, like that arrow in the diagram shows. So in other words, if we want to rotate one point, this point here is 1, 2, 3, 4 units in that direction, the X direction, 1, 2 up. So if we want to go to the counterclockwise direction 90 degrees, we go to our other axis, 90 degrees around. So now we're looking at the y-axis, and we'd go up 1, 2, 3, 4, left 1, 2. So there would be that point rotated 90 degrees counterclockwise. And if you notice, 2, 1, it followed that rule of negative yx and became negative 1, 2. Okay, so that's why that rule works for rotating 90 degrees counterclockwise. Okay, so we just did step 2. We rotated it. The new point A was at negative 1, 2. So what did we notice about the coordinates of the rotated point? Again, xy becomes negative yx for our 90-degree counterclockwise rotation. All right, so now we're going to look at rotating a figure more than 180 degrees. So again, if you're using patty paper manually, you can trace this. We're going to just look at the rules since I'm doing this digitally in a video. So skip into part B, rotate the figure 270 degrees clockwise. So our rule for 270 degrees clockwise is going to be that xy becomes negative yx. Okay, so again, if you took each one of those points, if I went 90 degrees, this point is 1, 2, 3, 1, 2. So 1, 2, 3, 1, 2, it moved to here. And I could do that with each one of my points. I'll do that one time around. Just trying to erase some stray marks here. There we go. So point S, so 7 on the X and then up 2. So up 7, left 2. That new point would be here. Our new Q, if we count that change horizontally and vertically, it would move here. And our last point, point P, would move there. So there would be a 90-degree rotation counterclockwise. Now if we wanted to go 180, now I'm going 3 this direction, down 2. So there would be our new red point, our new yellow point, 3, so up 4, down 3. Oh, I went the wrong direction, and I erased my wrong point. Let's try that again. So 2, 3. So up 3, left 2, up 3, down 2. There we go. And so this one went up 3, left 4. So up 3, left 4. New yellow point would be here. Our new blue point, 2, 3, 4, would be here. And our new green point there. So there would be 180 degrees. And if we want to go one more time and get to 270 degrees, our new red point would be at 2, negative 3. All my drawings went away. All right, we'll get it. Something in my pen keeps doing that, and I'm still working on figuring out that reason why. New blue point would be here. New green point and yellow point. All right, but you get the idea. We're just rotating around that center origin as our point of rotation. Okay, that's our point we're rotating around. And so 270 degrees is going to move you 3 quadrants. 180 degrees is going to move you 2 quadrants. 90 degrees is going to move you over 1 quadrant. But it all goes back to that rule that I wrote down here at the bottom, which simplifies it. Of a 270 degree clockwise rotation is a negative yx movement. Okay, so keeping that in mind, we're going to go write the coordinates of the original rectangle, PQRS, and we're going to write the coordinates of this new rectangle, 270 degrees, using our rule. All right, so we got PQRS, and then we're going to have our new image, PQRS. So those original points, if you flip back to the other page, are 3, 4, 7, 4, 3, 2, and 7, 2. So we're using that rule of negative yx for a 270 degree counterclockwise rotation. So that means this is going to become negative 4, 3, if we follow that rule to move those points around. Q is going to become negative 4, 7. R is going to become negative 2, 3, and S is going to become negative 2, 7. So compare the coordinates. How are the values the same? How are they different? Again, the 270 degree rule, counterclockwise rule, is xy becomes negative yx. And that will find you the points of your figure rotated 270 degrees counterclockwise. All right, next figure. They give us a triangle shown on the coordinate plane. Again, they want you to do the same thing. Take patty paper, trace it. If you're doing it manually, I highly suggest trying that so you can visually see the rotation. And again, we're just going to look specifically at the rules. And it says rotate it 360 degrees. Hey, well, 360 degrees goes completely around in a circle and ends you back up at the same point. So a 360 degree rotation will end always like I said, my pen keeps messing up on me. It keeps moving it. Always. There we go. Back where you started. There we go. Finally got it in. I think we might need a new pen here. So 360 degrees is always going to end up back where you started. So in other words, the coordinates of the pre-image are going to be the same as the new coordinates. Okay, if you want to go in and fill those in, you can. But all we're looking at here is, if we go back to that triangle, L, M, N, new L, new M, new N from the new image, they're not going to change. Like point L is at 6, 4, the new, or negative 6, 4. The new one's at negative 6, 4. They're the same. I'll go ahead and fill those in just so you can see them. Negative 1, 6, negative 1, 6. Because a 360 degree rotation does not change anything. So in other words, 360 degree rotation, I wouldn't even call it a rule, because all that means is that XY is going to stay XY. The points aren't going to move. They're going to be the exact same. All right, so on this page, we're just going to write down our rules now. So it's talking about point XY, and if we just in generic talk about that point, what the rotations mean. So a rotation about the origin 90 degrees counterclockwise. So that is where we have our point changed to negative y x. Okay, and keep in mind, 90 degrees counterclockwise. Remember, 1 quadrant is 90, 2 is 180, 3 quadrants get you 270 degrees. So I could also go 270 degrees clockwise, 1, 2, 3, and I would end up at the same figure as the 90 degree counterclockwise movement. That's why those rules are the exact same. Okay, 90 degrees clockwise. That is going to be y negative x. Okay, if you think of that point, the x isn't changing to move 90 degrees clockwise, but the y is, or the x is becoming negative, and the y is swinging positive and going in that x spot. And then rotating 180 degrees around the origin, it doesn't matter if we go clockwise or counterclockwise because you're going to end up in a straight line 2 quadrants away no matter where you go. So that's just negative x, negative y is that rule. So again, all these rules are on that separate sheet I'm giving you. Do not lose that. Keep that handy. Makes rotations very simple as far as understanding where the new points go when we rotate a figure different degrees. All right, so filling in all these. So again, just examples. So if we want to go 90 degrees counterclockwise for this figure, so counterclockwise, again, we're using the rule negative yx. So this point would become negative 4, 3. This point would become negative 1, 6. This point would become negative 9, 4. For the next one, 90 degrees clockwise. 90 degrees clockwise is using the rule y negative x. So those points are going to be 4, negative 3, 1, negative 6, 9, negative 4. Now I would encourage you to pause the video, try to use the rules, fill in the rest of them, and then unpause the video to check to make sure you did this right. So 180 degree rotation is negative x, negative y. So negative 3, negative 4, negative 6, negative 1, negative 4, negative 9. All right, I'm going to go back to black color here. So 270 degrees clockwise is going to use our rule negative y x. So again, filling in those points, you should get negative 4, 3, negative 1, 6, negative 9, 4. And then our last rule we're looking at, 360, remember, it doesn't change it. It just stays x, y. So the original point, 3, 4 for the first one for A, 6, 1 for B, 4, 9 for C is unchanged. Okay, so there's an example of all our different rotations using our rules. So A, what do you notice about the coordinates of the triangle that's been rotated 270 degrees clockwise about the origin? Okay, that is going to be the same. I mentioned this a minute ago. You could say 270 degrees counterclockwise is equal to 90 degrees clockwise, and vice versa. Okay, and then B, what do you notice about the coordinates of a triangle that's been rotated 360 degrees? It stays the same. Remember, 360 degrees does not change anything. All right, so again, same thing. Now we just don't have a figure, but we got our rules. So if we take this figure and rotate it 90 degrees counterclockwise, so 90 degrees counterclockwise, we're using our rule negative y x. So our new D would become negative 10, negative 7. Our new E would become negative 5, negative 5. And our new F would become positive 8, negative 1. Okay, how did you determine the coordinates? Using our rule, negative yx for 90 degrees counterclockwise. All right, now we're going to do the same thing 90 degrees clockwise. So 90 degrees clockwise, we're using our rule of y negative x. So that's going to give us the points. Our new D is 10, 7. Our new E is 5, 5. And our new F is negative 8, 1. I encourage you to go graph these and just see what they look like so you can see the rotations. So how did we determine the coordinates of the image without graphing? Again, using the rule y negative x for 90 degrees clockwise. All right, if DEF is rotated 180 degrees about the origin, what are the coordinates of the vertices? So 180 degrees, remember, it doesn't matter which direction we go, counterclockwise or clockwise, it's the same rule, negative x, negative y. So if we follow that rule, our new D, and hopefully you're catching on to just using our rules to find our points, our new E, 5, negative 5, and our new F would be at 1, 8. So how did we determine the coordinates of the image without graphing? Again, using our rule, negative x, negative y, for 180 degree rotation. All right, and just going through this last one, and again, I encourage you to pause it and try it, try to figure out the changes. We got multiple changes, transformations here going on. So if you pause it and try it, what you should find when you unpause it, number one, we're trying to see if they are congruent. Yes, they are. What we had here was a 90 degree counterclockwise rotation, negative yx, and translated 1 up, 1 unit up. For the second, what you will find is these are also congruent. And we had a translated, so it was slid, 1 left, and down 6 units. Okay, we got 2 more. Again, for 3, you'll discover these are congruent also. And it's translated 5 left and 5 up. So in other words, up 1, 2, 3, 4, 5, and then left 1, 2, 3, 4, 5 to get our new image. And then the fourth one, again, they are congruent. This one's a little trickier. It is reflected. You can see the flipped image. Say across the y-axis. And translated down 2 units, down 2, and right 1. All right, and we're going to stop there. We're going to skip past the last page. I'm not too concerned about you worrying about that page. Again, just understanding your rotation rules, using the rules from that sheet that are going to be given to you that's printed out. Make sure we hang on to that, lose that. Being able to take a point and manipulate it using those rules to find your new coordinates based on your rotation, either being 90 degrees, 180, 270, or 360, and whether we're going clockwise or counterclockwise.